We can see here lens is the transparent medium bounded by two surfaces. One is spherical and the other may be plane or spherical. Means both the surface may be spherical or one of them is plane and other may be spherical there. And according to it, we have classified there are 6 types of the lenses here. Is that we have seen here: biconvex lens, plano-convex lens, concavo-convex lens. These are for the convex types of lenses. And for concave type of lenses, we have biconcave lens. Both the surfaces are concave. And here, plano-concave lens. One surface is plane, other is concave. And here, convexo-concave lens. One surface is convex and other is concave. Now let us see about the deviation produced by the lens. Are you listening me? Are you getting my voice or not?
Yes.
Yes, sir.
We are last time lens is the combination of prism. And what the role played by the prism? Prism produces the deviation and therefore the thin lens also produces the deviation. That is, it changes its path. Deviation means changes its path. The thin lens produces the deviation of the lens. Now let us consider here the thin lens that we can show here. This is the lens L, and suppose we can consider here having the focal length 8 here. Now here we can show the optical axis. This is the optical axis of the lens. Now consider the monochromatic light ray PQ that we can consider here. The monochromatic light ray PQ parallel to the principal axis. That we can see here. The light ray PQ is parallel to the principal axis. Incidence on the lens at a height h from the axis that we can see here. That you are getting is this, that is we can say the monochromatic light ray PQ incident on the lens at a height h. Now see here, if the lens is due to this lens, what happens? The light ray changes its path that we can see here. And it travels here along the path QF. It travels along the path QF. F is what? F is the focus point or focal point of the lens. F ला आपण काय म्हणतो? फोकस किंवा focal point. Focal point of the lens. Now, in the absence of this lens, the light ray travel along this dotted line. That we can see here, this is the straight path. But due to this lens, it goes under changes here. Now, here delta represent the deviation. Now, what we have seen here, this is the original path of the light, but due to the lens, it changes its path along QF, and therefore this represents the deviation produced by the lens, that is delta here. Do you get this? Now see that PQ is the original incident ray, but due to this lens, it travels along QF. Otherwise, it may travel here along this dotted line. And therefore, the deviation here is delta. The deviation produced here is to be delta. Now, here The distance between the optical center and the focus point is called as the focal length. Now see from this geometry. Here deviation is how much? Deviation produced by the lens is
2f.
9. Deviation produced by the lens.
Delta.
Delta, right. Delta is the deviation produced by the lens. बघा या ठिकाणी PQ हा ओरिजिनल पाथ आहे. जर हा लेन्स नसता तर तो असा सरळ निघून गेला. But because of this because of this lens, it changes its path and travel along QF. म्हणजेच काय बघा या ठिकाणी एवढा डेल्टा एवढा त्याच्यामध्ये चेंज झालेला आहे. लक्षात. Now see here from this geometry. From now here we have this triangle. This angle is delta. Now see here, if this angle plus this angle is how much? Suppose that we can consider this angle as to be gamma here. याला आपण मानून घेऊ या ठिकाणी. Suppose here this angle is to be gamma. Then gamma plus delta is equal to how much? बघा ही फिगर अशी आहे. This one is H. This is delta. And this is gamma. Gamma plus delta is equal to how much?
Total height.
नहीं gamma plus delta angle है बघा हा. This angle is delta and this angle is gamma. Just 1 minute. Hello. मी नंतर करतो जरा लेक्चर मध्ये आहे. हाँ ठीक. Here gamma plus delta is equal to 90 degree.
90 degree.
Gamma plus delta is equal to 90 degree. Now see here in this triangle then. QOF. In this triangle, if we consider this angle as to be alpha here, suppose. In this triangle, this angle is of 90 degree. Therefore, gamma plus alpha is equal to how much? Gamma plus alpha is equal to how much? बघा ट्रायंगल आहे हा. ट्रायंगलच्या तिघ अँगलची बेरीज आपल्याला माहिती आहे 180 असते की नाही. मग त्यातला हा एक 90 चा झाला. That's why gamma plus alpha is equal to
135 degree.
No. Now see here, this angle is of 90 degree. This angle, one of the angle is of 90 degree. Then the sum of other remaining angles should be. बघा ट्रायंगलच्या तिघ कोणांची बेरीज तिघ अँगल 180 असते की नाही. त्यातला जर एक 90 झाला तर राहिलेला दोघं अँगलची बेरीज
45.
No.
90.
90 degree. That is of 90 degree. Right. ठीक है. Now we can compare these two equations. Comparing these two equations, gamma get cancelled and we get alpha is equal to delta. Alpha is equal to काय मिळेल आपल्याला? डेल्टा मिळेल या ठिकाणी. बघा अल्फा इज इक्वल टू delta. This angle is of delta then. हा इथे आपण represent केला. Now see here in this triangle then. In this triangle, tan delta is equal to what? Here we write tan delta is equal to what? Front side upon adjacent side. Front side का है? H. That we write here H upon L. If delta is very small, then tan delta is approximately equal to delta. And therefore, here we can write delta is equal to H upon L. Delta is equal to H upon L. Now let us consider this as the equation number 1. Delta represents deviation. Delta काय represent करतो या ठिकाणी? Deviation. H represents the height at which the light ray is incident. I mean, F represents focal
Focus
length.
out.
F represent the focal length. समजलं equation? Delta is equal to H upon F. लक्षात घ्या. Delta म्हणजे deviation, H means height, F means focal length. Now that we have considered here, the light ray is parallel to the axis, means the object is at a very far away from the lens here. Now we consider the another case here now. Now in another case, suppose the object is at point P here. The object is at point P on the axis, and therefore the light ray incident from the lens is now not parallel to the axis. That we can see here like this. The light ray incident on the lens at a height h again, that we can consider. Now see here, if now due to this lens, the light ray is refracted here and travels here along this. Suppose we considered here PQ is the incident ray, and then it will travel here along QF. This one is capital F, that represent the focal point or focus point. Now here again we can see the deviation produced supposed to be delta here. This is original path, but due to this lens, it travels along QF. It travels along QF. Now again here we can see that. Here this is the optical center of the lens, and therefore here this angle is delta. Now we can see here this angle is also again delta from this geometry. Now image is formed here. We get the image. Here is the object. Now that's why we can say here this one is object distance, that we can see here. This one is object distance u, and here the image is on the lens, sorry, on the axis of the lens at a distance v. Now see from this figure then. Again here delta is the deviation here. Delta is the deviation produced here. Now this angle is not delta here. Now from this figure then again, delta plus that we can consider here, suppose the incident ray PQ, and then we can write here delta plus angle PQI, angle PQI is equal to how much? Delta plus angle PQI. Now see, this is the straight line, and here the situation is like this. This one is delta and this one is PQI, suppose. This angle plus this angle is equal to how much? That is 180 degree.
Degree.
That is 180 degree. Again see here, in this triangle, angle QP, suppose here this is the optical center here, angle QPO plus angle QIO plus angle PQI. It is equal to 180 degree. Now we can compare this. Comparing this, we get, see that PQI get cancelled, and therefore delta is equal to, we get here angle QPO plus angle QIO here. That is this angle plus this angle is equal to delta. Now see from this figure, that is equal to, here tan delta is equal to what? Tan of this angle, that is front side upon adjacent side. That we write here H upon U. H upon U. But the object distance is to the left side here, and therefore it is negative. U is negative here. Plus, again here, H upon V. That we write here H upon V. This angle, angle QFO is equal to H upon V. We can take H as a common factor here. H common काढा. ब्रॅकेट मध्ये काय राहील? 1 upon minus 1 upon U plus 1 upon V. Or we can write here, it is equal to H in bracket 1 upon V minus 1 upon U. Delta is equal to this, H into 1 upon V minus 1 upon U. Do you know 1 upon V? V means image distance minus 1 upon U. U is object distance. 1 upon V minus 1 upon U is equal to what? 1 upon F. That is focal length. F is the focal length here. And therefore we get here delta is equal to. Delta is equal to what then? H upon F. Delta is equal to H upon F. This is our equation number 2 here. Now see here, when the object is at a large distance, and in that case we have get delta is equal to आपल्याला त्यावेळेला बघा इक्वेशन काय मिळालेलं होतं. डेल्टा इज इक्वल टू h upon f. Equation number 1 that we have seen. And now this is equation number 2. When the object is on the axis of the lens, equation 2. When the object is far away from the lens, that means when the light ray is parallel to the axis here. In that case, we get equation 1. Can you see if there is any difference between these two equations? तुम्हाला काही डिफरन्स दिसतोय का त्या इक्वेशन्स मध्ये? तुम्हाला डिफरन्स दिसतोय का दोघं इक्वेशन्स मध्ये? हे बघा.
No.
Yes. Delta is equal to h upon 1, h upon f, equation number 1. Delta is equal to h upon f is equal to equation number 2. Is there any difference? Very simple question. Equation 1 आणि 2 मध्ये काही फरक दिसतोय का तुम्हाला? Yes or no?
No.
No. Good. याचाच अर्थ काय होतो बघा. The difference, what we can say here, the deviation is not depends on the position of the object. Deviation produced by the lens is not depends on position of the object. It not depends on the position of the object, but it depends on what? Deviation is depends on h and f. H means the height at which the light ray is to be incident on the lens. H is the height at which the light ray is incident on the lens. And f is, what is f?
Focal length.
Focal length, right? F is the focal length. That is, we can say here, deviation produced by the lens is independent of the position of the object. Is independent of the position of the object. And it depends on height and focal length. Do you get this about deviation produced by the lens? Do you get this? What we have seen in this topic, the important thing is that the deviation is depends on, tell me. Deviation is depends on
H upon F.
h and f, right?
Yes.
H and okay. Now let us consider the equivalent focal length. Means if we have two or more lenses, that we can consider the combination of two or more lenses, and what is about their equivalent focal length. And we can then construct the single lens which have the same focal length as that of the equivalent focal length of the combination of two or more lenses. Then that lens is called as the equivalent lens. That means if we are, suppose here this is one of the lanes, another lens that we can see the present here, 1, 2, 3. And if their combined effect, whatever the combined effect of these three lenses is produced by the single lens here, then we can say this is the equivalent lens here. This is equivalent length. Now let us consider here, for our simplicity, the equivalent focal length of two lenses that we can obtain here. Consider here one of the lens L1. Consider the another lens here L2. One of the lens L1 and here another lens L2 here. And suppose their focal lengths are to be F1 and F2. Their focal lengths are to be F1 and F2 here. Now, both the lenses are mounted coaxially. Both the lenses are mounted coaxially, means their axis is same. Their axis is same here. Consider two thin lenses L1 and L2 of focal lengths F1 and F2 mounted coaxially. Let X represent the distance of separation between them. That we can represent. X represent the distance of separation between the lens. Here the medium is air. Here air is present. Now consider the light ray PA that we can consider here. This is the light ray PA incident on the lens. The light ray PA okay. This is the light ray PA is incident on the lens L1. This is parallel to the axis. The light ray PA is parallel to the axis here. And it incident on the lens L1 at a height H1 here. That we can see here. Now, if this lens is not present, then what happens? The light ray travels along this straight line. But because of this lens L1, the light ray is refracted here. That is, there is a change in the path here. And now suppose this light ray travels here along A. It travels along AB. AB is the incident ray for second lens. Now here the deviation produced by the first lens, we can assume it is to be delta 1 here. We can consider this deviation is delta 1. याला आपण delta 1 मानून घेऊ. येत आहे लक्षात? बघा, original path असेल, but the path is changed here like this. And that's why the deviation produced due to the first lens is delta 1. Now, AB is the incident ray for the second lens. Now, if the second lens is not present here, then the light ray travels towards F2 here. F1 we can consider. That is the focal point for the first lens. And therefore, we can say here this distance is F1, that is focal length for the first lens. This is the focal length for the first lens. Now then, but due to the presence of this second lens, the light ray travels along B F here. F is the focus point or focal point of this combination. The light ray travels along B. Here we can consider their optical centers O1, here another optical center for L2, that is O2 here. Because the distances are measured from optical centers here. Now then, O2F is equivalent focal length. O2F is equivalent focal length that we can represent here. Here O2F. Here it is F1. Now see here, this is the deviation delta 1 that we have assumed here. Now suppose deviation produced due to this second lens is delta 2 here. Deviation produced due to the second lens is delta 2 here. Now then, suppose here the optical center for lens L1 is O1 and for O2 for L2 here. And this is the equivalent focal length F here. And here focal length F1. Now then, see here in this figure then, deviation, total deviation should be how much? For that purpose, we can produce the incident ray PL and the emergent ray BF here. That is we can see. BF is produced in backward direction. BF is produced in backward direction. Now these two rays are met at a point H here. And therefore, here this is the total deviation delta. Because here this is the incident ray and this one is the emergent ray. That we can show here this like this. And that's why this is delta. And then we can write here delta is equal to delta 1 plus delta 2. Delta is equal to delta 1 plus delta 2. Now see here then, delta is equal to, according to our definition, the height, the ratio of height at which the light ray is incident to the focal length. Delta is the equivalent deviation, total deviation. And that's why we can write here, the height at which the light ray is incident is H1. Equivalent focal length F here is equal to delta 1 should be written as H1 upon delta 1 काय लिहिता येईल आपल्याला H1 upon F1 plus delta 2 is H2 upon F2. हे इक्वेशन लक्षात घ्या. Where delta is equal to delta 1 plus delta 2, and that is we can put the values of delta, delta 1 and delta 2 here. Now we have only 1 minute now. Please take the screen and put it on our group. If you have any difficulty in today's lecture, then ask me. आजच्या लेक्चर मध्ये काही अडचण आहे का? डेविएशन तर समजलं प्रत्येकाला. काय डेविएशन इज? अनम्यूट करा आणि सांगा पटकन. डेविएशन डेल्टा इज इक्वल टू नाही आलं लक्षात? h upon f. Deviation is h upon f. Can the deviation is depends on position of the object? Can the deviation is depends on position of the object? Yes or no? Deviation ऑब्जेक्टच्या पोझिशन वरती डिपेंड असतं का? नाही समजलं?